Hey everyone, welcome. We're going to jump right into a classic physics puzzle today. One of those questions that seems super simple on the surface, but it trips up almost everyone at first. It's a perfect example of where our everyday intuition bumps up against the really cool rules of physics. Okay, so picture this. You toss a ball straight up in the air. It shoots up, slows down, and for a split second, it just hangs there at the very top before it starts to fall back down. The question is, at that exact instant it hits its peak, when its motion has stopped, is it accelerating? What's your first gut reaction?
Now, if you're like pretty much everyone, your common sense is probably yelling, "No way, of course not." I mean, if it's not moving, its speed is zero. How can something be accelerating if it's not moving? It feels completely logical, right?
But as we're about to find out, what feels right isn't always the whole story when it comes to physics. So let's put that gut instinct on the shelf for just a minute and think like a physicist. Let's really break this thing down.
First things first, we're going to put that simple tossed ball under a physics microscope. By really looking at its journey, step by step, we're going to uncover the answer.
So let's map this out. First, the ball is moving upwards, right? We'll call that a positive velocity. Then it hits that highest point. That's the moment we really care about. And finally, it starts falling back down, which means its velocity becomes negative. It's that middle step. That's where the secret is hiding.
Okay, to crack this thing open, we have to get really clear on our definitions. First up, what exactly is velocity?
So in physics, velocity isn't just speed. It's speed plus a direction. And that little addition, the direction, is everything. 60 miles per hour is just a speed, but 60 miles per hour north, now that's a velocity. So, keeping that definition in mind, let's go back to our ball. At the very tippy top of its flight, in that split second where it's switching from going up to coming down, what's its instantaneous velocity?
Yep, you got it, 0. For that tiny instant, it's not moving up, it's not moving down, its velocity is 0 meters per second. So right now, common sense is looking pretty good, right? But we're only halfway there.
And now we get to the real heart of the matter. We've got velocity down, but to really solve this puzzle, we need to understand the second and honestly the most important piece, acceleration.
Okay, and here is the absolute key. The most important word here isn't speed, it's change. Acceleration is all about the rate of change of velocity. It's not about how fast you are going right now. It's about how quickly your velocity is changing. You could be speeding up, slowing down, or even just changing direction, and in all those cases, you're accelerating.
So let's look at our ball again. A split second before it hits the peak, it's moving up, positive velocity. A split second after the peak, it's moving down, negative velocity. So is the velocity changing? Oh yeah, big time.
And this is the mind bender right here. The velocity is always changing, the entire time. It's a continuous process. It doesn't just slam on the brakes and then hit the gas again. It's smoothly transitioning from positive to negative, and that change is happening even at the exact moment it passes through zero.
And what's driving all this change? Well, there's one force that's always on the job, gravity. From the instant that ball leaves your hand, gravity is pulling it down. It never lets up. And that constant downward pull creates you guessed it, a constant downward acceleration. And here on Earth, that acceleration has a value. It's about negative 9.8 meters per second squared. That minus sign just tells us it's pulling downward. And here's the thing, that number doesn't care what the ball is doing. It's pulling with that same strength when the ball is going up, when it's coming down, and yep, even when it's at the very peak.
All right, let's put all the pieces on the table. We have everything we need to solve the paradox. And this is where it all finally clicks.
Okay, so let's walk through it. 1. At the peak, the velocity for just a moment is 0. We know that. 2. But thanks to gravity, that velocity is constantly changing. 3. And what's our definition of acceleration? It's a change in velocity. So, conclusion. The ball is accelerating at its highest point. How cool is that? Even when it's totally still for an instant, it's accelerating.
And that right there is the whole idea. It's the perfect example of the difference between velocity and acceleration. Velocity is like a snapshot, what's happening right now. But acceleration is the movie. How is the snapshot changing over time? And you can absolutely have zero velocity and non-zero acceleration at the very same instant.
So, why do we even care about this little brain teaser?
Well, because this idea that a constant downward force from gravity creates a constant downward acceleration, that is the absolute foundation for understanding any kind of projectile motion. We're talking about everything from the arc of a cannonball to a satellite in orbit. It all comes back to this fundamental concept.
So, that leaves us with one last question to mull over. We've just established that gravity is always pulling down, always creating a downward acceleration on everything around us. So, think about it. Is anything on Earth ever truly, completely at rest? Something to think about. Thanks for joining this explainer.